Hello everyone, this video is going to be for chapter 3 lesson 4, which is about perpendicular lines. Now in the previous two lessons we did learn about some theorems. Hopefully you have memorized them or you would have understood them. Rather than memorizing, it's always better understand the lesson or understand the concept and then do the questions rather than just memorizing and doing certain stuff. It's not only for math, for every lesson it's the same. It's better you understand and then do it, because that will be in your mind rather than memorizing and doing it. So before we get started with the lesson, again, this lesson also has certain theorems. So let's get started with the theorems first. Now for the previous lesson, we did learn about the theorems of parallel lines and intersecting, no, the parallel lines and the angles. For this lesson, we are going to learn the theorems about perpendicular lines. Now, you know math is completely based on theorems from certain things which are already proven, so we are just learning them. So there are three theorems which you need to keep in mind when you're learning, when you're doing something about perpendicular lines. First of all, let me show you what perpendicular lines are. Perpendicular lines are two intersecting lines, but they do not just intersect, however, they do form right angles. These are called as perpendicular lines. Always they form right angles. These are called as perpendicular lines. Now, what are the theorems they're saying about these perpendicular lines? If two intersecting lines form a linear pair, hopefully by now you must be knowing the words or meanings of these words. Linear means straight, congruent means equal. So if two intersecting lines form a linear pair of congruent angles, then the two lines are perpendicular. In easy words, if two lines are intersecting and they're making straight lines with equal measures, that each should be 90 degrees and 90 degrees. Usually it's like that because the angles on a straight line is 180 degrees. Always remember the angles on a straight line are 180 degrees. So if you want to make this angle in two equal parts, how do you divide that? You must divide that into 90 each. Only then they both will be equal. So if two lines are intersecting and then they form a linear pair of angles, congruent angles, that means the two lines are perpendicular. So the reason we give for this is two intersecting lines form linear pair of congruent angles, then the lines are perpendicular. The next theorem says perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of the two parallel lines, so you have to go about very slowly with these theorems until you understand them. Once you understand them, you can just be a pro and do whatever you want with the theorems. But to understand them, we need to go slow. So let's read slowly what they say. In a plane, so it can be any plane. Okay, just imagine it's a plane. If a transversal, you by now you know what's a transversal. It's any line which will cut through two lines. So if a transversal is perpendicular to one of the two parallel lines, so first let's draw two parallel lines. So they said if a transversal, in the previous lesson we learned transversals were like this. But in this lesson they are saying if a transversal is perpendicular to one of the two parallel lines. So perpendicular means it should be like this, isn't it? So if it is like this, so this line is perpendicular to one of the parallel lines. Then it is perpendicular to the other line as well. Now this is easy understanding, right? If these two are parallel lines, let me name them as L and M. So L and M are parallel lines. But if line P is perpendicular to line L, that means automatically line P becomes perpendicular to line M as well. So that's what the perpendicular transversal theorem says. If a transversal is perpendicular to one of the two parallel lines, it will also be perpendicular to the other line as well. So this is perpendicular transversal theorem. Let's move on to the next one and see what they say. If two coplanar lines are perpendicular to the same line, so they said any two lines if it is perpendicular to the same line. So first let's draw one line. Okay, and they said if two coplanar planes are perpendicular, so if this is a line, perpendicular means it should be like this, right? two lines are perpendicular to the same line, then the two lines are parallel to each other. So it's like the opposite of the perpendicular, the inverse of the perpendicular transversal theorem. The perpendicular transversal theorem said if a line is perpendicular to one of the lines, one of the parallel lines, then it is also perpendicular to the other parallel line. But what does this theorem say? If two lines are perpendicular to the same line, then the two lines are parallel. Simple. So we give the reason as two lines perpendicular to same lines means the two lines are parallel. Let's now move on with the lesson and see what are the other kinds of things they have given in this question. So for exercise 1 to 4, name the shortest segment from the point to the line and write an inequality for x. Now here, let me give you another clue. Any point, any triangle can, this is a perpendicular line, okay? These are perpendicular lines. A line can be in any form. It can be like that, it can be here, or it can even be here. Now these are not triangles, but they look like triangles because we are joining the lines. Always remember, no matter how many lines are there, always the shortest segment will be from here to the perpendicular segment, from where the points meet to the perpendicular segment. So here we have four lines. This is line 1, this is 2, this is 3, and this is 4. Now among these four lines, if they would ask you which is the shortest segment, the shortest segment is always the one which forms the perpendicular segment. Not 1, not 2, not 4. It is always going to be the line which forms the perpendicular segment. So for this question here, they have asked you to write an inequality. How do you write an inequality? Now first let's find out the perpendicular segment from here. We have PR and we have PQ. So which is the perpendicular, which is the shortest segment? Of course, PR is the shortest segment. That's because this is the perpendicular one. PR is the perpendicular one. So how do we write this? We say PR is less than PQ, because any other segment is always longer than the perpendicular segment. So they denoted PR with X is going to be less than PQ is 3.5. So this is how you write an inequality. You choose the shortest segment and say that it is shorter than any other segment. Isn't that simple? Let's find out for this question. Now first find out which is the perpendicular segment. There are three. This is 1, this is 2, and this is 3. So which is going to be the shortest segment? Is it 1, 2, or 3? Yes, you're right. It's going to be the second one because that's where it forms the perpendicular segment. Can you see that it's marked with the right angle mark here? That's where it forms the perpendicular segment. So we could say JH is less than, always shorter than, which other one? We can say 1 or 3. But in this question, they have given the measurement for JI. So we say HJ or JH is less than JI, which means 11, JH is 11 is less than X plus 4. Now we don't leave it like this, we do solve it. All of us know how to solve inequalities. So 11 minus 4 is less than X, because the positive 4 moves to the other side, it becomes negative. So 7 is less than X, or X is greater than 7, which means the value of X here will be any number greater than 7, 7.5 or 8, anything. It's natural. See, if I would replace X is equal to 7 here, that would give me an 11, which means Ji will become equal to Hj, which is wrong because just now we studied saying the perpendicular segment is always shorter. So if it is shorter means it should be something more than 7. So say for example 8. 8 plus 4 would give us a 12. So now it's correct because Hj is 11. So Ji is longer than Hj, which means it could be 12 as well. So this is a quick way of checking whether the value you got for X is correct or not. Right, let's move on to the next question. Again, find out which is the shortest segment here. So the shortest segment here is AB because that's where it forms the perpendicular angle or perpendicular segment. So we could say AB is less than, which other measurement have they given? They have given us AC. If they would have given AD, we can use the measurement for AD. So what is AB? AB is 6, which is less than x minus 3. So 6 plus 3 is less than 9. Sorry, less than x. 6 plus 3 is 9, which is less than x. Or we can say x is greater than 9. So this is the inequality. Now for a checking, do replace x with 9. If I would replace x with 9, that would give me 9 minus 3, which is 6. It's wrong. So the value of x should be greater than 9. So take 10. So 10 minus 3 is 7. So this is 6. This is 7. Is that right? Yes, it is. So this is the correct answer. Again, for question 4, now there are two things here. There are two perpendicular segments. One is this one and one is this one. But we cannot use this because they did not give us any other measurements, right? So we are going to use these two, this particular triangle here. Let's see. First, the perpendicular segment is WU or UW, however you want to call it. So UW is less than UV. UW is x plus 4, which is less than 21. So x is going to be less than 21 minus 4. X is less than 21 minus 4 is 17. So x is going to be less than 17. Let's check if it's true. Now here already we have an x. So x is less than 17 means any number less than 17 could be 16. So can we say this side is 16 and this is 21? Yes, we can. So that means your answer is right. Which even you could replace x with 17 or 18 and check. If I would replace x with 17, that would give me both equal. 17 plus 4 is 21, then 21, both of them are equal, which means it's wrong. But if I would replace 17 with anything greater, x with anything greater than 17, say 20, so 20 plus 4 is 24, which means this particular side is now x is less than 17 means I have to replace it something less than 17, say 15. So 15 plus 4 is 19. So yes, it is lesser than the other side. Let's move on to the next question, number 5. Now here is a 2-column proof where we have to prove something which they are asking us. They have given us m is perpendicular to n. So this is the given information that m is perpendicular to n. Prove that angle 1 and angle 2 are a linear pair of congruent angles. So we need to prove that angle 1 and angle 2 are a linear pair of congruent angles. So let's start with what's given. The given information is m is perpendicular to n. This is the given information. In the next one, they have given us definition of perpendicular segment. So what is the definition of perpendicular segment? According to the definition of perpendicular segment, we could say angle perpendicular means 90 degrees. So we have to say the measure of angle 1 is equal to 90 degrees. And also the measure of angle 2 is equal to 90 degrees. Only then that would act as a definition of perpendicular lines, segments, which means angle 1 is 90 and angle 2 is also 90 degrees. Now from the above this part, we could say angle 1 is congruent to angle 2. Now what is the reason? Why are we saying angle 1 is congruent to angle 2? Because of the definition of congruent angles. So definition of congruent angles. Congruent means both are equal. So angle 1 is equal to angle 2 means definition of congruent angles. Now here what they have done is they have added, because we have to prove that it's a linear pair. Linear means it's straight. Now the first slide I did explain, that means the angles on a straight line must add up to 180 degrees. That's what they have done here. Angle 1 plus angle 2 equal to 180 degrees. Because of the addition property of equality, they have added both. Now what can we say about the definition of linear pair? Let me show you about the table here. Which one did they use? The definition of linear pair. No, that's not here, because they're talking about linear pair, which is straight. It's the same thing which I explained you about the straight line. So we can say angle 1 and angle 2 a linear pair, because we have already proven here it's equal to 180 degrees. So we have to say angle 1 and 2 are linear pairs of angles. That's because of the definition of linear pairs. Definition of linear pairs says that two angles added up must, if two angles are added, that should give 180 degrees. So that's why we say when we add angle 1 and 2, they are called as a linear pair, because when we add them, that would give us a 180 degrees. So let's move to the next question and see here. They have given the Four Corners National Monument is at the intersection of borders of Arizona, Colorado, New Mexico, and Utah. It is called the Four Corners because the intersecting borders are perpendicular. So if you were to lie down at the intersection, so if you would lie down at this point, you could be in the four states. Of course, that's true. If you would lie down here, your head, legs will be in all these four states at the same time. So you can be in four different cities at the same time. The only place in the United States where this is possible. So in United States, there is a place where the borders of these two in four different states are intersecting. So what the question is, the figure shows the Colorado-Utah border extending north. So you can see these are the borders. This is the border between Utah and Colorado, and this is the border between Arizona and New Mexico. This is the border between Arizona and Utah, and this is the border between New Mexico and Colorado. So similarly, they have given the Colorado-Utah border. If it extends, it is intersecting at Wyoming border at a right angle. So it's intersecting at this point. Explain why the Colorado-Wyoming border must be parallel. So this we have to explain. Let me just highlight that, what we have to explain. Become clear for you. You have to explain why this Colorado-Wyoming border should be parallel to the Colorado-New Mexico border. So we have to explain why this must be parallel to this. By now, once you highlight that part, you must be having an idea why that should be parallel. Because from those theorems, we did learn that if any one of the two, if any one line is if the line is intersecting any one of the two parallel lines or perpendicular to any one of the two parallel lines, that means both the lines are parallel. So let me show you that here. These two theorems where we said if in a plane, if a transversal is perpendicular to one of the two parallel lines, that means it is also perpendicular to the other line. Here also it said if the two lines are perpendicular to the same line, then the two lines are parallel. So here what we are going to explain is why should this two be always parallel. So what do you think we are going to use now? Though totally this depends on your way of explaining. But what I would say is the Colorado-Utah border, you can see the Colorado and Utah border is a transversal. For which one? For the Colorado-Wyoming one. Can you see this? The Colorado-Utah border, this one is a transversal for the Colorado and Wyoming border, right? Now because of that, what happens? The transversal is perpendicular to both borders, right? So let me just write this in my words. It's totally up to you how you are going to explain. Let me type this, it would be better rather than a writing. Okay. So let me write that here. Now you can have different ideas, but then the what do you say? The meaning should be the same. So Colorado-Utah border is a transversal to which borders? This is the Colorado. Oh, why did I write A here? It's Colorado-Utah border. This one. This border is a transversal to the Colorado-Wyoming border as well as the Colorado and New Mexico border. It acts as both. So let's write that to Colorado border New Mexico border. So because it acts as a transversal to both the borders, what happens? We can say because the transversal is perpendicular to both borders, the two borders must be parallel, right? Now we are only talking about these two, so we have to find a connection which will give us proof to say that these two are parallel. So the only connection we have is this line, which is the Colorado-Utah border, right? So it is perpendicular to both these borders, which means automatically, according to the theorem which we learned, we can say that because, oh, I'm making many spelling mistakes, because the transversal is perpendicular to both borders must be parallel. So this is how you explain. Now this lesson is particularly based on perpendicular lines. So that's why they have used these methods of using perpendicular lines to prove. Now, yes, you can, if it was not this particular lesson, you can even use the alternate, the same-sided interior angle theorems, even to prove that these two lines are parallel. If you would remember in the previous lesson, we did learn in the converse of the same-sided interior angle theorem. If the two angles must add up to 180, then the two lines are parallel. You could use that as well, but for this particular lesson, because it concentrates on perpendicular lines, so that's why we use this theorem where it says if one line is perpendicular to one of the parallel lines, then it should be perpendicular to the other line as well. So this is how you explain. But it must be, you can explain in your own words, it must be having the same idea, which is the second theorem which we learned. So this is how you choose according to the question the things to prove. Hopefully you would have got the answers right, but as I would always say, practice makes it perfect. So find out, there are many questions on the internet about proving. You can do many questions. So till we meet again in the next video, keep practicing.